Hey, I'm Jeff on the Rive team, and I did a previous video talking about relative binding and how to set it up in the editor and use it across library files. The key idea with bind relative is that when you bind to a property, it's the name of that property that is used to find the value, not the specific location. This time, we're going to look at how to use it at runtime and then swap out artboards using the same data properties. So to start with, I've got a user profile design set up here. And if I open my view model, I'll open the table view and we'll make it tall like this. We can see all the properties. I've got properties for the first name, last name, location, a job title, there's an about paragraph and a project description paragraph, and then some numbers for pals, awards, and projects. Full profile is a Boolean, and there's an image bound, and there's also an artboard property set up as well. And so if we look at the artboard itself, we'll find that we have several text runs where things are bound to those properties using bind relative everywhere. And we can take a look at what this looks like. There's a transition interaction to a full profile and then back to a preview kind of profile. But all of this data is coming from view models. So this is set up with relative binding, and we noticed there was an artboard property, and that is because if I want to swap this out for another artboard at runtime, what I'm going to do is make this into the component and nest it into a parent artboard. So this is going to be the exact same thing. In fact, all that's here is the artboard component itself, which is bound to that artboard property here, also bound relative. It's set to layout, and it's going to fill the parent layout. So any of the layout rules I had set up on the component will resize with this artboard as well. And because this is bound to that artboard property, this is one we can swap out for another artboard at runtime. Here, I have it set up in a web runtime environment, and I can interact with it just as we did in the editor. But this is ready to swap in another file. So Laura on the creative team at Rive created this version of the profile, and it's using properties of all the same names. In this case, the properties are in a view model called view model 1, whereas in the original, they're in one called profile view model. But the property names are all the same, although they are in different orders as well. And that doesn't matter with relative binding. As long as the names are the same, then they can be used with relative binding. So we can export it as a .riv and use it at runtime. In this setup, I created a variable for the artboard property, and it's going to be used in a function that will pull from this Rive file, user profile by Laura, and it's going to get the artboard, the main artboard in the file. And when I uncomment this function, we'll see that it switches to the version that Laura created, and it's using all of the same data from the original. And because that's just being swapped into the artboard, all of the data bindings are still working. And just to illustrate that even further, here is one more version. In this case, it's got a view model called main, but this time the data doesn't match. Here we've got projects, awards, and pals are all set to 0. It says first and last for the names, city name and state, job to, so it's all this just generic information here. So even when I preview, it is using the data that is in this file. But when I swap this one in at runtime and load it into this file, which does have the user's correct information, it will work. So if I choose that file, it's going to pull in all of the correct information from the view model in the original file. We can do something more complex with this too. Let's say we have something like a dashboard that has multiple components in it, and you want to be able to swap out the way your data is being displayed. So the setup of this file includes a lot of relative binding and also some nested view models. So first I have the continent view model, and this is where I know I have these 7 continents, and I'm going to want the same kind of data for each one. So I know I want the population number for the continent, the name of the continent, so I can bind it to strings. There's also a percent and a consistent color for each continent. So if we look at this in the table view, we can see all these properties being made available to all the other components. The components have nested properties of the continent view models, and one for each of these instances. So I've got a nested continent view model with the Asia instance, which is going to allow me to access this set of data. So for Asia, I will have the color, the name, and the population. Same thing for Africa, color, name, population. So in the component view model, I'm getting access to the information from the continent view model for each of the 7 continents. And then those are being used in the dashboard view model, especially when we're placing in the artboards in the slots here. So for something like the map component, this is the component that I'm actually placing into the dashboard view model here. And it has a nested component itself of this map, and that is so that I can use the leaf layout property. And this component has the component view model, and it also has some nested components from the tag component down here. So this tag, you'll notice, isn't bound to a view model itself, but the text run is bound relative to a population value from the continent view model. So I'm not specifying which population, just that a population goes here. And you can see the path is, it's not specifying any particular nested path, it's just a relative path. And because it's a number, it's converting it to string. And so when I place that into an artboard that has the component view model attached to it, I have all those nested properties from the component view model. So for each of these, this is a nested component from the continent view model. I can assign one of those to each of these. So for this one, that's over North America. I'm going to choose North America from the component view model and component view model. So that lets it pass in the population data for North America into this component. And so I'm doing the same for each of these. There's South America, Africa, Oceania, and Asia. So many of these have nested data within them. And there are several cases where, I don't want to rebind all of these things. I don't want to bind the number and the country name for each of these. So I can create one component that is bound to just the population value, for example, but relative, and let the binding in this component determine how it works. So that lets me set up several different types of components. I've got there's a donut chart, there's vertical bars, there's the stacked bar chart, and the table with the information. And then each of these is just bound to a slot and is using the component view model. So I can drop in any other component at runtime that uses data with the same property name. So here it is set up in my runtime. I've got all the responsiveness working the way I have it set up. I'm using the same view model properties for all of these components, and it's ready to swap out for another component. Let's say I want to create another type of visualization for this data, and I want to use a scripted layout for this, something that might be a little bit harder to create on my own. So I have this script that creates these 6 circles that will resize themselves based on the actual population data. But I'm working in a separate file, and I have a view model that's just called library component view model, and it has nested instances of another view model called view model 1. But in view model 1, you'll notice I do have the % population name and color, which are the same property names as my other file is using. And the nested instances for each of those are called the same thing as what I have in my other file as well. I also added the text color and background color properties here so that when I want to update those colors at runtime, they will work here as well. In this file, if I view the view model, which would be like the continent view model that has the specific information for the continents, I only have one instance here. And in fact, all of the nested versions here are referencing the same instance, but because they have different names, and I'm using relative binding, these can find the correct properties in the host file when I load this file into the host file. So I can preview this here. Even though I don't have the actual data, I know that it's set up to take the actual data. So let's look at that at runtime. I'm gonna swap out this donut chart for the circles graph. And this is set up to load that external file and place it into artboard slot number 5, which is down here in the bottom corner. So when I uncomment my swapping code, we can see that that does get swapped out and all of the data is getting matched up with the same data from all the other components. The colors match, the numbers match, and in this case, the relative sizes are matching as well. And because I had put in text color and background colors, those can be updated at runtime as well. So let's say I want to make the text red. I'll put in a hex value and we'll see that works across all of the components. And this is the background color for the components themselves. So let's say we want to make it blue. So because that was bound using those same properties, that will work across all of the components. So that's how relative binding can be extremely useful at runtime, so that you can use an existing view model's properties as long as you have an artboard that's using a view model with the same property names.